So we have this function here, and this is the graph of it here. Crosses at point A, which is A0. The line L is the tangent at point B, so it just touches it there. Find the exact value of A. Well, look at this function, and this is where the y value is 0. So I can just put part A, f of A equals 0. Therefore, log of x squared subtract 16 equals 0. Do an e to the power of both sides to make the log disappear, so e to the power of 0 is 1. Maybe I'll put that to show what I've done. X squared subtract 16 there. And therefore x squared equals 16 plus 1, which equals 17. Square root x equals positive negative root 17. And a is greater than 0, therefore x equals root 17. Therefore, a equals root 17. Part B, given the gradient of L is 1/3, find the coordinates of B. Well, if the gradient of L is 1/3, that means at that point the gradient of this is 1/3. So let's go back to f of x. F of x equals log of x squared subtract 16, and I need to find f dashed of x. And this is a chain rule, so let's do u equals x squared subtract 16, du by dx equals 2x, and the negative 16 then disappears. And that means that y equals log of u, dy by du equals 1 over u. So therefore f dashed x equals 1 over x squared subtract 16 from this piece, multiplied by 2x. And we know that f dashed of that value there is, from the exponent will be f dashed of x. I want to be 1/3. Therefore 2x over x squared subtract 16 equals 1/3. Let's multiply by x squared subtract 16 and by 3. That means we get x squared. This becomes 6x, and I'll subtract it from both sides to get x squared subtract 6x subtract 16 equals 0. Let's just check for factors of 16, negative 16, 1 and 16, 2 and 8, 4 and 4. One has to be positive, one has to be negative, and I want to get negative 6, so we'll take 2 and negative 8. Therefore, x plus 2, x subtract 8 equals 0. And then now I'll do the x equals negative 2 or x equals 8. And x is greater than 0, therefore x equals 8. And it wanted the x coordinate b, therefore b, x coordinate of b is 8.